n, this thing is then delayed. This is delayed. Delayed का मतलब simple ये होता है कि wherever this n is, you replace this n by n minus n naught. अब आप में से किसी ने somebody asked me कि जी what if we advance? If you want to advance, that's fine. But the thing is, वो causality जो है ना वो restrict करती है आपको कि you have to, your output cannot be, your system cannot be a predictive one. तो इसलिए यहाँ हम एडवांस की बात नहीं कर रहे, डिले की बात कर रहे हैं. For when we delay the system, this should become y1 of n minus n naught. ठीक है? So wherever this n is, I replace by n minus n naught. ठीक है जी? ये पहला स्टेप है. सेकंड स्टेप है वो ये कहता है कि you take an input and delay it first. ठीक है? So you take an input and delay it. Once you delay it, this will become x1 of n minus n naught. Let's call this input x2 of n. Okay. This passes through the system here. Okay. And obviously, I'll get some y2 of n because x2 of n, so I'll get y2 of n. If y2 of n equals y1 of n minus n naught, then we say this implies system S is time invariant. System S is time invariant. अब मैं इसको आपको एग्जांपल देता हूँ इसका. Suppose करें you have an antenna on top of the main block. ठीक है? So you have an antenna on top of the main block. And you have an antenna on top of the new electrical building. ये जो electrical building है ना, जब हम पढ़ते थे ना इसको, this is called the new electrical building. So you have an antenna on top of the main block and you have the antenna on top of this electrical building जो gate 3 के पास है. मुझे ये बताएं कि if I measure the signal strength, or suppose I can measure the signal. So if I can measure the signal at 9 o'clock in the morning, वो ये कह रहा है. So x1n is a signal जो मैंने at main block किया और electrical की building के ऊपर at 9 a.m. I measured this signal. ठीक है जी? अच्छा. So I have this signal measurement at 9 a.m. and then what I did was same signal, I delayed it and I measured it at 5 p.m. ठीक है? So I measured it at 5 p.m. same electrical की building के ऊपर. So the thing is, the system or the channel, इसको channel कहते हैं. So the channel between the main block and the electrical building, क्या वो time invariant है या variant है? याद रखें कि your antennas are fixed on rooftops. बड़े-बड़े antennas लगे हुए हैं, कोई मसला नहीं है उसमें. आपको example समझ आया मैं क्या कहने की कोशिश कर रहा हूँ? So you want to do measurements at 9 a.m. and 5 p.m. So first system is कि you do a measurement at 9 a.m. और उसको आपने संभाल के रख लिया. So you have stored it और वो आपको पता है कि वो measurement क्या है. दूसरी you make the measurement at 5 p.m. So ये वो वाला है कि 9 की जगह आपने इसको delay कर दिया 5 p.m. पे, and then again you measure the signal received at the new electrical rooftop antenna. My question to you is कि जो 9 o'clock आपने measure किया था signal, is it going to be the same as the signal you measured at 5 p.m.? If it is, then you say the system is time invariant. If it is not, then you say the system is not time invariant, it is time varying. अब मुझे ये बताएं कि जो मैंने आपको example दिया, is this a time invariant or a time varying system? Anyone जी? तो बहुत स्टूडेंट्स हैं भाई, कोई भी जवाब दे दे. कितने हैं? काफी हैं, थोड़े ही हैं वैसे भी. बताएं जी. Anyone? भाई बाकी स्टूडेंट्स क्या सो रहे हैं? बाकी कौन गए? काफी हैं. बताएं जी, जवाब दें. Anyone? If I measure signals on rooftop of electrical engineering building, fixed antenna on top of electrical and engineering building, the second antenna is on top of the new block. Signal is measured at 9 a.m. and 5 p.m. Will I get the same measurements? ये question है बस. If I get the same measurements, then we say the channel is time invariant. If I don't get the same measurements, then I say that channel is time varying. Channel का मतलब है the medium between the transmitter and receiver. Yes, see. Anyone? कोई भी? Yes or no? ये कोई स्टूडेंट है या सारे चले गए हैं अपने वो लॉग इन करके?
तो सर ये टाइम वेरिएंट लग रहा है.
टाइम वेरिएंट होगा? क्यों? व्हाई? वजह भी बताए ना. अब आपने एक बोल दिया टाइम वेरिएंट होगा, तो क्यों होगा?
सर y की इनपुट n और x की 3n, तो हर दफा वो ट्रिपल होता जाएगा.
नहीं, अभी तो हम इस सिस्टम की बात ही नहीं कर रहे भाई. अभी तो मैं आपको उस सिस्टम की बात कर रहा हूँ कि आपका एक एंटेना इज ऑन टॉप ऑफ द मेन ब्लॉक जो इलेक्ट्रिकल में है, ओल्ड साइड के ऊपर, पुराने तरफ जो ऑडिटोरियम की तरफ है, और एक एंटेना इज ऑन टॉप ऑफ द न्यू इलेक्ट्रिकल बिल्डिंग जहाँ आप पढ़ते हैं अभी, अगर आप पढ़ते हैं गेट 3 के पास. So what I'm asking you is, if I'm making measurements at 9 a.m. and I'm making measurements at 5 p.m., will I get the same measurements or not? मैं सिर्फ आपसे ये सवाल पूछ रहा हूँ. अभी तो हम X3n को देख ही नहीं रहे, वो तो हम बाद में देखेंगे. बताएं जी. नोटेशन जो है ना इस लाइक दिस, पता नहीं ये कहीं बनी हुई थी या मैंने खुद ही बना दी है. Anyway, so x1 of n passes through the system, you get y1 of n. y1 of n, when you delay it, you get y1 of n minus n naught. ये पहला है. Second में you have x1 of n. You delay this, you get x1 of n minus n naught. This is known as x2 of n. x2 of n, when passes through the system, you get y2 of n. So you want to check whether y2 of n, so check y2 of n is equal to y1 of n minus n naught or not. अगर ये है, if they are equal, then it's, so if this is equal, this implies S is time invariant. If it's not, otherwise S is time varying. ठीक है जी. बताएं जी. चले उसको छोड़े, आपको समझ ही नहीं आया मेरे ख्याल में जो मैंने आपसे क्वेश्चन पूछा. हाउ डू आई प्रूव कि दिस सिस्टम इज इसको सोचिएगा बैठ के, मुझे जवाब दीजिएगा इसको कि इज दिस, जो मैंने आपको एग्जांपल दिया, वाज इट टाइम वेरिंग और टाइम इनवेरिएंट. अच्छा जी. सो इस एग्जांपल में, सो यू हैव x1 of n. When this passes through the system, you get y1 of n. y1 of n is simply x1 of 3n. ये सिस्टम है. This is what the system does. System ये कहता है कि down samples by 3. अच्छा. So when I want to delay it, when I delay, I simply replace n by n minus n naught. n is replaced by n minus n naught. इसका मतलब this will become x1 of 3. इस n को replace कर दें n minus n naught. बल्कि इसको इस तरह लिखें. Don't write it like this. Okay, एक step बीच में खास देंगे. So y1 of n, when I delay it, I'll get y1 of n minus n naught. But y1 of n minus n naught, this n is replaced here. So this becomes x1 of 3 into n minus n naught, which is equal to x1 of 3n minus 3n naught. Okay? So this is from the first output. Second के लिए हम ये करेंगे कि you have x1 of n. I delay it. I get x1 of n minus n naught. This is equal to x2 of n. ठीक है. x2 of n, when passes through the system, I get y2 of n. ठीक है. But what is y2 of n? Y2 of n is simply x2 of 3n. यही होगा ना? Because output is simply x times 3n. So if the output is input at downsampled by 3. So अगर y2 है तो यहाँ x2 है, so y2 is x2 of 3n. But what is x2 of 3n? x2 of 3n का मतलब ये है कि यहाँ जो n है, इस n को आपने 3n कर दिया, इसका मतलब ये जो n इधर है इसको हो जाएगा. So this y2 of n is simply x1 of 3n minus n naught. ठीक है? अगर x2 of, यहाँ मैंने इसको चेंज करूँ ना 3n से, so this is not going to change. The only thing is going to change is this n. So I'll have x1 of 3n minus n naught. Are they two equal? बताएं जी. Are they two equal? This is a two-step process to check whether the system is time invariant or not. Are they two equal or not? No, they are not equal. So this implies, so this is not equal. So this implies this system is time varying. Okay, clear? What about linearity? So linearity के लिए you want to prove it like this. So ये सारी हो गई है ना? 1, 2, 3, 4, 5, 6. ठीक है. अच्छा. Linear के लिए you prove it like this. You say, so there are two parts for the to prove linearity, or there are two checks. Sorry, there are two checks to prove linearity. One check is the homogeneity. इसको स्केलिंग भी कहते हैं, homogeneity और scaling. ये वो कहता है, so this implies x1 of n passes through the system, gives you y1 of n. x2 of n, which is some a1 x1 of n, when passed through the system gives you y2 of n. But this y2 of n should be equal to a1 of y1 of n. Okay? So if this is true, then you say that this is system is scaled. जिसका मतलब ये है कि if you scale the input, the output is scaled by the same amount. ठीक है? जिसका मतलब ये है, if you have input scalar is 0, so if you multiply by 0, the output should be 0. और इसीलिए we said कि y is equal to mx plus c is not a linear system. Why? Because if I put m is equal to 0, I still have y is equal to c if c is not equal to 0. So ये जो था ना system y is equal to mx plus c. If the c is not equal to 0, when I put m is equal to 0, this y is not equal to 0. So this is not linear. This system is not linear. This is an affine system. ठीक है? So whenever you have an input, whenever you have scalar, उसके साथ अगर आप zero, the scalar is 0, the output should be 0. So no input, no output. This is as simple as that. So if there is no input, so in a linear system there will be no input, no output. ठीक है? The second one is additivity. So additivity के अंदर, additivity means that you have x1 of n gives you y1 of n. और इसी तरह इसको प्रूव करना है आपने. x2 of n passes through the systems gives you y2 of n. ठीक है जी? Then you have some x3 of n. x3 of n is the sum of the two. x1 of n plus x2 of n. When this passes through the system, you'll obviously get y3 of n. ठीक है जी? अब if y3 of n is equal to y1 of n plus y2 of n, इसका मतलब है कि your additivity property is satisfied. Okay? So you'll have some x1 will give you y1, x2 will give you y2, then you pick some input which is a sum of the two, this will give you some output. If this output is the sum of these two previous outputs, then you say that the system is additive. इन दोनों को combine कर दें, you have the principle of superposition. और वो ये कहता है कि a1 of x1 of n plus a2 of x2 of n when this passes through the system, you should get A1 of Y1 of n plus A2 of Y2 of n. So there are many examples that I've done in the video lectures. जिसको आप देख के ना you can easily see that this is how this linearity property is satisfied. इस example में क्या होगा? So x1 of n gives you y1 of n, and y1 of n is simply x1 of 3n. ठीक है जी? x तो मैं additivity property देख लो. So I'm looking at the additivity property. x2 of n passes through the system, you get some y2 of n. Obviously y2 of n is x2 of 3n. ठीक है? Because system जो है ना, याद रखें, your system is this one. कि x of n gives you y of n, and this y of n is this y of n is actually x of 3n. ठीक है? So ये जो input है, इसका जो index है n, that becomes 3n. ठीक है? So this is what we have done कि x1 of n gives you y1 of n, but since ये x1 है तो यहाँ this y1 of n is simply x1 और n की जगह I have done 3n. ठीक है? अच्छा. So let x3 of n equals some x1 of n plus x2 of n. It's kind of like when it passes through the system, I get some y3 of n. But what is y3 of n? y3 of n is simply x3 of 3n. x3 of 3n. But what is x3 of 3n? उसमें ये है कि this n is replaced here, this n is replaced here. So I get x1 of 3n plus x2 of 3n, and this is equal to, but what is x1 of 3n? This is y1 of n, this is y2 of n, this is y1 of n, this is y2 of n. This is how you prove additivity. You see, there is no other way of proving additivity. So you take some inputs x1 and x2, then you take a third input, which is the sum of these two, pass that input through the system, you'll get some output. Is output को try to write it in terms of the previous in terms of the outputs corresponding to the previous inputs, and if you are able to write that, then you say the additivity property is satisfied. ठीक है जी? और अगर जी आपने इसको प्रूफ करना है स्केलिंग के लिए, तो यू से कि x4 of n is some a x of n. ठीक है? x4 of n is some a1 x1 of n. ठीक है जी? अच्छा. So when this passes through the system, I'll get y4 of n. But what is y4 of n? y4 of n is simply x4 of 3n. ठीक है ना? यही होगा, because this is the system. So y4 of n is x4 of 3n. But what is x4 of 3n? x4 of 3n का मतलब ये n is replaced by this one. So we have a1 x1 of 3n. But what is a1 x1 of 3n? This is simply a1 y1 of n. So if my input is scaled version of my input, then my output, ये वाली output, is a scaled version, same scaled version of the output corresponding to the previous input. So this is how you satisfy the homogeneity or scaling property. You need to satisfy both. If both are satisfied, then the system is linear. If one of them fails, then the system is not linear. ये याद रखें इसको. So for a linear system, and there are examples in the video lecture, जिसमें one is satisfied, the other fails. For a linear system, or a linear system should satisfy both additivity and scaling properties. अगर ये वो नहीं करेगा तो then there is a problem. ठीक है? Then it's not linear. इसमें कोई क्वेश्चन है जी? इस एग्जांपल में ये मैंने बहुत टाइम इस पे खर्च कर दिया. I spent a lot of time on this example because you're not responding. I think अभी कोई आफ्टर इफेक्ट्स हैं मेरे ख्याल में रात को उठ के प्रेस करने के, अगर आपने किए हैं. So in any case, so I've spent a lot of time on this example. कोई क्वेश्चन है इसके अंदर? Any question? Any question जी? Yes or no? You need to actually answer either yes or no. हाँ जी, ऊंचा बोलें जरा. Any problems? Yeah, any questions?
No, sir.
No, sir. Good, Chief. Okay, so next example is this one. So I have three more questions actually. Y of t. So whatever we have said for y of n actually holds for y of t2. इसमें कोई मसला नहीं है कि एक के लिए कोई और है दूसरे के लिए कोई और. Sine of 2t into x of 2t. याद रखें कि our convention is this is the input and this is the output. This is some factor which is time varying. कोई फर्क नहीं पड़ता. This is some amplitude or scaling time varying scaling factor. Time varying scaling factor. This is not the input. ये ना परेशान हो जाइएगा कि this is the input. Input is always x, output is always y. ठीक है जी? चलिए. We have to again see. अच्छा इसमें सारी नहीं करनी. So we have to see whether this is memoryless. We want to see whether this is causal. We want to see whether this is time invariant. And we want to see whether this is linear. सारी नहीं करनी, बस ये करनी है. बताएं जी. Is this memoryless? याद रखें memoryless में at time output at time t depends only at input at time t. So output at time t, is it only depending on the input at time t? ऊंचा बोलें जी, ऊंचा. मुझे आवाज नहीं आई आपकी.
No, sir.
No, sir. So output at time t is not depending on input at time t, but the output at time t is actually depending on input at time 2t. ठीक है ना, यहाँ 2t है. So this system is, so output at t depends on input at 2t. ठीक है जी? So this implies this has system has memory. So system has memory. ठीक है जी? Good. अच्छा जी. What about causal? All memoryless system are causal. ये last time भी किसी ने मुझसे question पूछा था. All memoryless systems are causal. Other way around नहीं है. ठीक है? Causal बताएं. Is the system causal? Causal में your output at time t depends on the previous, present and previous, not the future values. So causal में output at time t depends only on the input at time t or t minus alpha, where alpha is some positive number. It cannot depend on t plus alpha, where alpha is a positive number. बताएंगे yes or no?
No, sir.
This is not causal. Very good. So this is not causal because output at t equals 1 कर लें, depends on input at t equals 2 times 1, no? 2 times 1, which is 2, which is a future value, which is a future time instant, इसको कह देते हैं, which is a future time instant. Good. So this is not causal. इतने से चेक होता है, इतने कौन सी बड़ी बात है. What about time invariance? Again, it's a two-step process, so we are going to do the two-step process. I'm not going to कोई वो बीच में shortcut लेना. पहले step में x1 of t passes through the system, you get y1 of t. y1 of t is delayed, you get y1 of t minus t naught. चलें, ये करके देखें. So x1 of t, when passes through the system, you get y1 of t. So y1 of t यहाँ मैं लिख देता हूँ, is sine of 2t into x1 of 2t. 2t या t है? So y1 of t, अगर मैं यहाँ y1 करूँगा, so this is sin 2t x1 of 2t. ठीक है? And when I delay it, इसका मतलब जितना जो t है, this t will be delayed, replaced by t minus t naught. So every t will be replaced by t minus t naught. So y1 of t will become sine 2 into t minus t naught into x1 into 2 into t minus t naught. याद रखें, whenever you delay, you always replace t by t minus t naught. अच्छा, एक और भी convention याद रखें, because when you're writing on the piece of paper, या आप अगर brackets में confuse हो सकते हैं, तो always start with the parenthesis, move on to the square brackets, and then use curly braces. ठीक है? And then go back to the parentheses, square brackets and curly braces. इस तरह आपने you know कि यहाँ से कहाँ से brackets शुरू हुई हैं, कहाँ brackets खत्म हुई हैं. अगर if you are always using parentheses, ये जो brackets होती हैं, ये curly है, this is a square bracket and the last one is a curly brace. अगर आप हमेशा ये parentheses use करेंगे ना, you won't know where the parentheses started and where it ended. ठीक है? So whenever you delay, you always replace t by t minus t naught. चलें, ये तो पहला पार्ट था. सेकंड स्टेप में हम ये करेंगे, we have some x1 of t. x1 of t is delayed. You get x1 of t minus t naught. इसको I call it x2 of t. ठीक है जी? x2 of t is passed through the system. Obviously, I get some y2 of t. But what is y2 of t? y2 of t is sine of 2t and x2 of 2t. x2 of 2t, because our system is this one. Your system is yt is sine 2t x 2t. Okay? So y2 of t will be sine of 2t into x2 of 2t. अच्छा. अब इसमें if I write it in terms, so but what is x2 of 2t? x2 of 2t में I am only going to replace this t. ये वाला कोई और change नहीं होगा. So this will become sine of 2t into x1 of 2t minus t naught. This is not 2t minus 2t naught. Okay? Are they two same? Are they two same?
No, sir.
No, they are
No,
not.
sir.
So this system is time varying. मैं पूरा ही लिख देता हूँ एक दफा ताकि next time मैं जब लिखूंगा तो कोई मसला नहीं. This system is time varying. ठीक है? इसको अगर आप स्टेप इन दो स्टेप प्रोसेस को बस अपने दिमाग में बिठा लेना, दिस इज हाउ यू प्रूव अ सिस्टम इज, तो कोई प्रॉब्लम नहीं होगा. द टाइम इनवेरियंस इज द ओनली थिंग जिसमें आपको कोई प्रॉब्लम हो सकता है, अदरवाइज एवरीथिंग इज फाइन. व्हाट अबाउट एडिटिव? सो आई विल डू एडिटिविटी, यू डू स्केलिंग. ठीक है? सो एडिटिविटी के लिए, सो लीनियर में वी हैव टू शो एडिटिविटी and you have to do show scaling. So I'll do additivity, you do scaling. So additivity के लिए we have x1 of t passes through the system, we get y1 of t. And what is y1 of t? This is simply sine of 2t into x1 of 2t. And x2 of t, so you have to have two inputs, और उससे आपने third input बनानी है. Passes through the system, you get y2 of t. This is sine. Sine is simply a scaling factor. This is not an input. एक वो time varying कोई एक amplitude है जिससे जो change हो रहा है sine. Sine 2 of 2t into x2 of 2t. ठीक है? So these are the दो inputs, you get two output. Then you say let. So याद रखें, let x3 of t equals sum of these two. x3 of t is the sum of these two. When this passes through the system, I get y3 of t. y3 of t is simply sine of 2t into x3 of 2t. ठीक है ना? ये इनपुट ये है, आउटपुट ये है, तो ऑब्वियसली ये इनपुट है, ये आउटपुट है और ये इनपुट है. तो इधर भी ये आउटपुट है, दिस इज द इनपुट. बट व्हाट इज x3 of 2t? x3 of 2t इज इस t को मैं चेंज कर दूंगा and I'll get sine of 2t. Bracket में I have x1 of 2t plus x2 of 2t, which is simply sine of 2t into x1 of 2t plus sine of 2t into x2 of 2t. Obviously, this is y1 of t, this is y1 of t, and this is y2 of t. since y3 of t is a sum of y1 of t and y2 of t, we say additivity is satisfied. Additivity property holds. Additivity property holds. ठीक है? You do it yourself. So do at home. Scaling भी satisfy हो जाती है. Scaling में भी कोई मसला नहीं है. So you satisfy both additivity and homogeneity. Challenge. Next question. ये कौन सा वाला है? 19. So next question is, you have this system y of n equals x of n into x of n minus 2. ये x, this is not n. So your output is actually product of two. Output is product of two inputs. एक original input है, one is the delayed input, and you have to show whether the system is stable, system is in time invariant, and system is, चलो आपके ख्याल में ये linear है? Is this linear? ये linear है? Is this system linear?
No sir, ये quadratic type का मेरा.
Because ये product है, ये multiply हो रहा है. So how can it be linear? So let's see कि ये linear है कि नहीं है. This is inverse. Invertible. चलें जी. Is the system stable? तो stability के लिए आप क्या करेंगे? So stability के लिए you will say xn is less than some bx, which is a finite number for all n. ठीक है? So if xn is less than some bx, which is a finite number, this implies yn magnitude is going to be the magnitude of x of n and x of n minus 2. यही होगा ना? Which is equal to, so product of magnitudes क्या होगा? Magnitude of the product is the product of magnitudes ठीक है? So magnitude of the product is the product of magnitudes. Since x of n is less than bx, this is also bx, so this is less than b square x, and let me call this equal to some by. So this some number by, which is less than infinity for all n. So this implies system is stable. ये समझ आया जी हमने क्या किया? We are going to say कि x of n का magnitude is less than some finite number. Let's call that number bx. This is true for all n. ये चीज जो है, this is for all. अच्छा. Yn ka magnitude is the magnitude of the product because this is the system. So y output, but this is product of the magnitudes. Each individual is bx. Each individual is less than bx. It's kind of the product is going to be less than b square x. B square x, अगर ये एक finite number, तो obviously b square x is also a finite number. So we say that number is by, and obviously this is a finite number for all n because these are individually less than bx for all n. So we say that this system is stable. So this is how you check stability. What about time invariance? Again, two-step process. Time invariance में first step, x1 of n passes through the system, you get y1 of n. But y1 of n is what? Simply the product of x1 of n and x1 of n minus 2. Okay. Then I delay this one, so I get y1 of n minus n naught. So this is y1 of n minus n naught, so ये n change हो जाएगा और ये वाला n change हो जाएगा. So I'll get x1 of n minus n naught into x1 of n minus n naught minus 2. ठीक है? अच्छा. Second step में क्या होगा? Second step में I have again x1 of n I delayed this one, I get x1 of n minus n naught. Let me call this x2 of n. So this is some input x2 of n. I pass this x2 of n through the system. I'll get y2 of n. Y2 of n is simply product of x2 of n and x2 of n minus 2, because this is what the system does. It takes the product of the two, one is as is, the other is delayed by 2. But what is this equal to? So x2 of n का मतलब है x1 of n minus n naught, और x2 of n minus 2 का मतलब है जब मैं इस n को, so इस n को when I replace here, so this will become x1 of n minus n naught minus 2. ठीक है? Both are the same, so since y1 of n minus n naught is same as y2 of n, this implies system is time invariant. ठीक है जी? Is this clear जी? Yes or no?
Yes, sir.
Good जी. What about linear? So let's do linear, and again I'll do additivity, you do homogeneity. अगर चाहिए additivity satisfy हो जाती है, अगर नहीं satisfy होती है, then it's all right. You don't have to prove homogeneity. So additivity means you have x1 of n. x1 of n passes through the system, you get y1 of n. y1 of n is simply x1 of n into x1 of n minus 2. Our gut feeling says it's not linear, but let's prove it. So x2 of n, when passes through the system, you get y2 of n. y2 of n is again x2 of n into x2 of n minus 2. Then I'll do let x3 of n equals the sum of the two inputs, x1 of n plus x2 of n. x3 of n passes through the system, I get y3 of n. But what is y3 of n? This is simply x3 of n into x3 of n minus 2, because the system takes the product of the two. But what is x3 of n? x3 of n is x1 of n plus x2 of n into x3 of n minus 2 is क्या, replace this n by n minus 2 is x1 of n minus 2 plus x2 of n minus 2. There will be four terms. So four terms के लिए multiply करें. So we'll have x1 of n into x1 of n minus 2. Good. This is y1 of n plus this one and this one, x2 of n into x2 of n minus 2. Good. This is y2 of n. Then I have plus x1 of n into x2 of n minus 2. ये पता नहीं कौन सी term है. Plus x2 of n into x1 of n minus 2. Obviously, this is not equal to y1 of n, because this was only y1 of n, this was y2 of n. ये दो terms और भी आ गई हैं, y2 of n. So this implies additivity property fails. So you don't have to do homogeneity. Additivity messy हो गया मैं यहाँ. So additivity property fails. Okay? So this system is non-linear. System is non-linear. So you write NL. Okay? What about invertible? Is the system invertible? How do I prove invertible? Invertibility के लिए you have to have 1-to-1 mapping. 1-to-1 mapping should exist between input and output. Between input and output. Exist करती है जी? As a 1-to-1, how do you prove? तो या तो आप इसको प्रूव करें या यू पिक एन एग्जांपल, कोई भी एग्जांपल जो इसको फेल कर दे. कोई एक इसको काउंटर एग्जांपल कहते हैं. तो पिक एन एग्जांपल जिसमें ये फेल हो जाता है. चलो मैं आपको एक एग्जांपल देता हूँ. So if x of n is some a times delta n, ठीक है, a is some number, a is a scalar, ठीक है, 10, 20, 30 जो मर्जी कर लें, 1.5 जो मर्जी कर लें, doesn't make a difference कि ये इंटीजर है कि नहीं है. So if x of n is equal to a times delta n, this implies x of n minus 2 is simply a of delta of n minus 2. ये n को आप रिप्लेस, तो जब आप n minus 2 लिखेंगे, so this n replaced by n minus 2, ठीक है जी. So this implies y of n equals, which is x of n into x of n minus 2. ये क्या होगा? ये चीज जो है ना, ये बता रही है आपको कि you have a at n is equal to 0, इधर सब कुछ 0 है. This is x of n. And then x of n minus 2 is like this. This is x of n minus 2. If I multiply both, what do I get? If I multiply both, what would I get? क्या मिलेगा मुझे? Yes or no जी, क्या मिलेगा? What will I get if I multiply the two? I have an impulse at n is equal to 0. I have an impulse at n is equal to 2. जब delay हो जाएगी, तो this is the impulse I get here. If I take the product, what do I get?
सब जीरो नहीं हो
These
जाएगा.
two signals are overlapping or non-overlapping?
नॉन ओवरलैपिंग.
If they are non-overlapping, obviously 0 होगा. या 0 पे ये एक्ट करिए या ये 2 पे एक्ट करिए, तो obviously जब आप मल्टीप्लाई करेंगे, यहाँ 0 का मतलब ये है कि यहाँ 0 है, और यहाँ 2 का मतलब यह है कि यहाँ 0 है. So whenever you multiply these two, obviously the answer is going to be 0. इसका मतलब so if you have a scaled impulse, your output is 0. इसका मतलब if the output is 0, you don't know whether the scalar was 5 or 10 or 1 or 2 or 3 or minus 1 or minus 2, right? Yes or no? So since you have a 0 here, so a 0 here gives you, so this implies a 0 in the output, a 0 in the output, a 0 in the output gives you no information, about A, the scalar A. ठीक है? Since it gives you no information about the scalar A, this system is not invertible. जब भी आपके पास आउटपुट 0 आ जाएगी, तो इसका मतलब you can never recover the input कि वो input का scalar क्या है. So this system is not invertible. ठीक है जी? अच्छा जी. So last example is this one. You have system 1, which is y1 of t equals x of 2t minus 4, and you have another system, the discrete time version, it's not y1 of t, this is y of t, and this is also y of n. This is y of t, this is y of n. This is x of 2n minus 4. You need to tell me whether the system is time invariant. So time invariant and invertible. These are the properties you have to prove. Okay? So let's start with time invariant. So first system, so time invariant property, time invariant again, two-step process. First one is x1 of t passes through the system, you get y1 of t. y1 of t is simply x1 of 2t minus 4. This is 2t minus 4. This is delayed when this is delayed, you get y1 of t minus t naught, which simply means this is x1 of 2 into t minus t naught minus 4, which is equal to x1 of 2t minus 2t naught minus 4. ठीक है जी? Yes or no? Can you hear me जी?
Yes, sir.
अच्छा अच्छा. Second step में you have x1 of t, you delay it, you get x1 of t minus t naught, call this x2 of t. Pass it through the system, you'll get some y2 of t, but y2 of t is simply x2 of 2t minus 4, which is equal to, replace this t by 2t minus 4, so replace this t by 2t minus 4, this will become x1 of 2t minus 4 minus t naught. Doesn't make a difference whether I write 2t minus t naught minus 4 or 2t minus 4 minus t naught. Are they both equal? Are they both equal?
No, sir.
No. So this is system is time varying. System is time varying. Let's do the same thing for system 2. So system 2 may, again you want to show time invariance first. Time invariant. So again you have first step may, you have some x1 of n passes through the system, you get some y1 of n. y1 of n is simply x1 of 2n minus 4. Delay this output, you get y1 of n minus n naught. So replace this n by n minus n naught. If you replace this n by n minus n naught, this will become x1 of 2 into n minus n naught minus 4, which is equal to x1 of 2n minus 2n naught minus 4. ठीक है, उसी तरह जिस तरह ये पहले वाला था इसका कंटिन्यूस टाइम में. सेकंड स्टेप में you have x1 of n, delay it, you get x1 of n minus n naught, call this x2 of n. Pass this through the system, you'll get y2 of n. y2 of n is simply x2 of, जिस तरह ये x1 of 2n minus 4, this is x2 of 2n minus 4. But x2 of 2n is simply, this n is replaced here, so this will become x1 of 2n minus 4 minus n naught. Obviously, same case as the previous one, they are not the same, so system is time varying. System is time varying. Challenge. How do we prove invertibility? So invertibility के लिए, invertibility, let's start with system 2. So system 2 is x, y of n. Y of n is x of 2n minus 4. What is the system doing? पहले तो ये बताएं ना. What is the system doing?
Downsampling and delay.
Exactly. It's downsampling and delay. अब इसको थोड़ा सा think करें. So visualize करें इसको. और ये मुझे बताएं कि so this is doing, so this is a delay and this is downsampling. अब assume some x, so assume some input, और उस input को if you delay and downsample, what will you get? So suppose करें you have this x of n here. So you have some x, ये कर देते हैं, this one, इधर, और ये चल रहा है यहाँ, ठीक है? And this is 0, -1, -2, +1, +2 +3 and so on and so forth. ठीक है जी? अच्छा. So if I delay and downsample and suppose करें I have, इसको मैं कह देता हूँ, so I say, and then what do I do is I have this signal again. इसको क्या हुआ? Can you see my screen जी अभी?
Yes, sir.
अच्छा जी. I will redraw this signal, और redraw करने की actually मुझे जरूरत नहीं होनी चाहिए. So I won't redraw. मैं इसी को पकड़ के ना इसको कॉपी कर लेता हूँ. So I'll just copy this one, और मैं इसके नीचे रख देता हूँ. अच्छा जी. अब मुझे ये बताएं. So tell me. अच्छा. So ये इसके odd samples कौन से हैं? 0. So इसके odd samples ये वाले हैं. इसके odd samples को ना मैं इसको उड़ा देता हूँ. इसको मैं 0 कर देता हूँ यहाँ. Sorry. I'll make this one 0. 3 को भी मैं 0 कर देता हूँ. -1 को भी I make it 0. So let's say this is x1 of n. This is x2 of n. What will be the output? All I've done is in both these cases, only the odd samples are different. Only odd samples are different. So when I delay and downsample, what will I get? If my odd samples are different, when I delay, what will I get? When I delay and downsample, what will I get? बताएं जी. Anyone? If I delay and downsample, what will I get? Will I get the same answer or not? मैं आपसे ये पूछ रहा हूँ. इसको इमेजिन कर लें, इमेजिनेशन से ही हो जाएगा. You don't have to sketch it or redraw it. जब आप करना चाहते हैं तो कर लें. So when I delay this x by 4, if I delay x1 n by 4, तो obviously ये सारे even पे ही चले जाएंगे ना. Everything would be even. अगर जो 0 है तो ये 0 4 बन जाएगा, 2 6 बन जाएगा, 3 1 whatever, so and so forth. और उसके बाद when I downsample, तो I am actually downsampling the even number sampled. I'm going to make them all 0, right? Yes or no? ये देखें ना, if I make this as x1 of n minus 4, this simply means that this will become 7, this will be 7, this will be 6, so 6 here, 7 here, this will be 5, this will be 5, this will be 4, this will be 3, ये 3 हो जाएगा, ये 2 हो जाएगा, and this will be 1. ठीक है जी? So this is some x1 of n minus 4. And what is x1 of 2n minus 4? अगर मैं इसको x1 of 2n minus 4 कह दूंगा. So what I'm doing is, so 2n minus 4 का क्या मतलब है? y0 would be equal to x minus 4, वो कुछ नहीं है. y1 भी नहीं होगा. y1 will be 2 minus 4, which is minus 2, यहाँ कोई नहीं है. y3 would be 6 minus 4. 6 minus 4 ये 2 है. We'll pick this one. ठीक है ना? This will be equal to y3. ठीक है जी? अच्छा. y4 क्या होगा? y4 will be 8 minus 4. ये y4 हो जाएगा. This is y4 and this would be y5. ये जो 6 वाला है. 10 minus 4, so this is y5. बाकी सब 0 है. So this is 0, ये नहीं होगा यहाँ. This will be not there. This will be not there. And obviously this would be not there. So you'll have value at values of 2, 4 and 6. ये कौन से वाले थे? ये even sample थे ना आपके पास, because आपने delay was even number थे, even से किया. Same case here. अगर इधर भी मैं यही करूं, suppose करें, so this will be 6. ठीक है. So this is x2 of n minus 4. x2 of n minus 4. This would be 4. And this would be, again, this would be 3, this would be 2, and this would be 1. Okay? And again, if I do x2 of 2n minus 4, if I do x2 of 2n minus 4, so I am going to pick, कौन से वाले थे? ये 2 वाला pick करूंगा मैं. ये आ जाता मेरे पास. ये 4 वाला मेरे पास आ जाता. और मेरे पास ये 6 वाला आ जाता. ठीक है ना जी? So I'll have these 3. So this is again some, maybe I call this y1 of 5, y1 of 4, y1 of 3. So this is y2 of 3. This is y2 of 4. And this is y2 of 5. y2 of 5. Is y1 of n and y2 of n the same? So is y1 of n and y2 of n the same?
Yes, sir.
Since y1 of n and y2 of n are the same, but the inputs were not the same. Inputs were not the same, so obviously from the output I cannot get back to the inputs because the only difference between the two inputs was that my odd samples were different. Since the odd samples were different, but I'm getting the same result. So because I'm getting the same result, I cannot go back and see whether my odd samples were the same or not. So if the odd samples are different in two sequences, we'll get the same output. So this system is not invertible. This system is not invertible. Clear है जी कि नहीं है? Yes or no?
Yes.
Achha, so you have to just give me a counter example just to show that the system is invertible or not. घर जाके आप ये खुद करें. So what about S1, y of t is equal to x of 2t minus 4. इसके बारे में बताएं. Y of t is equal to x of 2t minus 4. What is the system doing? ये क्या कर रहा है system? Again, this is the delay. Is this compression or expansion?
Compression.
This is compression. This is compression. इसका मतलब if I have an inverse system that gets rid of this delay, maybe advances it, and some expansion which counters the compression, I should be able to get my signal back. So ये घर जाके इसको देखिएगा कि delay की जगह you advance and compression की जगह you do expansion. If you do that, would you be able to recover the signal? So inverse system should advance and expand, and you should be able to get back your original signal. If you can, then your time counterpart, the continuous time counterpart system is invertible, but your discrete time counterpart system is not original. If you get back the original signal or not. So ये इसको देखिएगा, ठीक है? The last thing that I want to do is कि I want to emphasize that you need to know how to sketch. You need to know how to sketch. So let me ask you this thing. If I give you this figure, tell me what is this in terms of the basic functions. 0, 1, 2, this height is 1, this is x of t, this is some t. How do I write x of t in terms of impulses and unit steps. You don't have to use both. जो मर्जी use कर लें. How do I write this equation of this one, x of t, in terms of unit steps and impulses? Yes or no? What is this portion? What is the slope here? Hanji? What is this portion? ये कौन सा portion?
Ramp.
ऊंचा ramp है, yes, ramp, but इसकी equation क्या? What is the equation for this portion?
X of t is equal to t.
Exactly. So this is x of t is equal to t. And how do I write this portion of the graph? If I only have to write this portion of the graph, how do I write that? T times what? I only want to write this portion of the graph. ये वाला. What do I do? T times what? How do I isolate this portion from this x of t?
0 से 1 तक impulse multiply कर दें.
Impulse? If you multiply an impulse, you are sampling it. You will only have one value. Unit step. Unit step is like this. A unit step or a unit gate? This one or this one? Gate. And this gate from where to where?
0 to 1.
0 to 1. Exactly. So 0 to 1, this is simply u of t minus u of t minus 1. Because u of t is like this. U of t minus 1 is like this. This is minus 1, this is plus 1. When you add them up, this is the only portion that you are left with. जो ये बना हुआ है. So this is t times u of t minus u of t minus 1. What about this portion? What is the equation here? So plus, what is the equation here?
X of t is equal to minus t.
No, this is not x of t is equal to minus t. X of t minus t is this one. This is minus t. Right now, because if it's 0, so then it's 0. ये तो 0 नहीं है. X of t is equal to minus t जो है, x of t equals minus t. When t is equal to 0, this should be 0. This is not 0. This is 0 at this point पे. This is not 0 at 0. This is minus t, but shifted by what? To the 2. This is minus t shifted by plus 2 or minus 2?
Plus 2.
Plus
minus 2, sir.
No. This is minus t shifted by plus 2 or minus 2?
Sir, advance से plus 2 करेंगे.
Plus 2. So this is plus 2 minus t. ठीक है ना? Plus 2 minus t. And again, this is the gate. This is the gate here. So if I want to, so इसको अगर I shift by 2, so this will be over here, and then I'm only actually interested in this portion. Okay? So again, I have this gate function which is from u of t minus 1 to u of t minus 2. Okay? So kindly review ये अपना sketching है. Sketching is very important for chapter 2. Chapter 2 में when you do convolution, most of the time we are going to do graphical convolution. So graphical convolution के लिए you need to know how to sketch, and whether when you reverse the signal and then when you shift it by positive or negative, whether are you delaying it or advancing it. ठीक है ना? तो इसमें आप so whether you are delaying it or advancing it. So जब आप minus t कर देते हैं तो वो plus 2 जब आप करेंगे, so that is actually a delay. It's not an advance. ठीक है जी? So let's stop here. We are done with chapter 1. So chapter 2 के लिए you need to review the first 2 video lectures. I think पहले ही काफी है. पहले 2 ही करने पड़ेंगे. There are 4 video lectures. So actually at least review at least review the first one. The first and the second are actually similar. First is on discrete time convolution. The second one is on continuous time convolution. And then there are the properties and the solution of differential equation and the difference equation. So if possible, review both the lectures, the first two lectures on LTI systems. Our focus is going to be on linear time invariant systems. So review those before coming to the lecture on Monday, inshallah. I don't know whether the timings are going to be changed. There was a notification last night that the timings, university timings are from 10 to 4 now, but I think this 8 o'clock is fine with us. So we can still do 8 and we'll be done early in the morning instead of starting at 10 and going up to 11:15, 11:30, which is half of the day is gone. So I would still think that we just do it at 8 o'clock unless the university shuts me down, stops me from doing that. But in any case, let's plan on meeting at 8 on Monday, inshallah. Okay, so if you have any questions, you can still send me an email. But please do review the first two lectures of linear time invariant systems, which are already in your class materials folder on MS Teams, and then I'll see you on Monday, inshallah. And before I let you go, let me download your attendance, and then I'll let you go. By the way, anyone who joins after 8:45, I don't mark his presence. Attendance मैं mark नहीं करता, ये मैं आपको बता दूंगा. If you have not seen it, so anybody who joins after 8:45, they are absent. So if you can't get up at 8, and you can't join before 8:44.59, I don't think so. You should bother signing in. Because in any case, I would mark you absent. Okay, so I'll see you on Monday, inshallah. Thank you.